So far we covered the central repository and the single user instance. So any questions on that? Any questions on central repository as single user instance? Alright, so I'm putting you all on mute. So if you have a question, you can ping me or you can unmute yourself and ask me a question. So today we will be looking at the multi-user instance of the central repository and also the different transformations, the platform transformations. We'll start with platform transformations today. And for your information, we will have a session for at least 1.5 hours to 2 hours today. So is it okay, because yesterday morning I could not take and tomorrow morning I'll not be able to take because I'll be traveling. So today I want to cover most of the part. So is it okay if you guys have any plans? Do let me know. All right, thanks. All right, so we were looking at the concept called central repository and single user instance. So it's not exactly single user instance. We were looking most at the central repository. Okay, so how to create a central repository, we have seen that. Then we have seen how to upload the code with objects and dependents, and with filtering into the central repository. I have a doubt. So we have a question here. Before we start, I have a doubt about the repository. I am not able to connect the repository what we have configured, and I will send you the errors with a screenshot. Yeah, Gopal, do send me. I'll let you know like how to clarify that. Just send me the screenshots and also the error with clear description so that I can let you know what has to be done. All right, so yeah, we'll do one more thing. If we have some good sort of errors, what we can do is we can pool all of them together and have them as a learning dictionary for this batch. Okay, so whenever you are practicing on your system, if you have a good error, like a reasonable error which repeats quite often in the real-time scenarios or in the real-time projects, so what we will do is we will create an Excel sheet with a column, first column as serial number, the second column as the error name, and the third column as the error type, which type of error is that, and the fourth column as root cause, and the fifth column as resolution. So we'll create a table like serial number, name of the error, type of the error, root cause and resolution, and we will keep it going forward. We will keep it as a common repository for all you people, and whenever you face some problem, you try to fill in that and circulate circulate that back to me. So once at the end of the course, you'll have some 50 to 60 valid errors. So that is what I'm expecting. And even in the future, if you get to see that error, so instead of thinking or instead of doing an analysis, you can easily find out like, okay, this I have worked on, this is the root cause and this is the resolution. You can blindly go and do that. So I'll create that sort of structure and I'll be sending it to all of you so that you can keep it on your system. Whenever you get an error, when you are practicing, just take a screenshot, put it in that Excel and send it back to me. I'll consolidate all those things. Okay. So apart from that, we are looking at the central repository. So we have seen concepts like creating a central repository. What is a central repository? What are the different aspects that we can do using a central repository, like check-in, check-out, history, delete, compare, and we have also seen the get latest version and labeling. So these are the different options that we have seen. All right. So now let us look at an enhancement to what we have seen yesterday, that is called the concept of a single user instance and a multi-user instance. So single user instance and multi-user instance. For example, let us assume that we have two sorts of projects going on in our company. One is a SME and second one is an LE. So SME will have a single user instance, like it will have one user who can create and design the code, and he can upload the final version of the code into the central repository. All right, so it's a single user instance. And in case 2, we have multi-user instance where we have, one second, where we have a central repository and we have multiple users who are working on different jobs. Okay, we have multiple users working, and all these users will be connecting to the central repository. So this is a different concept when it is compared to a single user instance. So what we have to do when you have only single user working on a central repository, and what we have to do when we have multiple users working on the central repository. So probably the security part of the central repository is not required when you are working as a single user instance, because uh, there is only one user who knows what to delete and what not to, and he has a complete set of authentications on him, and he knows what he has to upload into the central repository or what he has to keep in the central local repository, and nobody is going to override, so there is no need for him to do a check-in or check-out or log the objects in the central repository. So this guy is aware what he is doing, and this guy, when he is working on a single user instance, every day he takes a backup of the job in the form of .atl file. Okay, because you need to remember one thing: the repositories or the systems on which we are working are volatile. They're not standard, so at any point of time the system might crash. So it is always the best practice that you take a backup of whatever the changes that you have done on the job on a daily basis. And if in case yesterday you did some changes and today you're not making any changes, so it's okay to have yesterday's backup. But if you are doing any changes on the code, it is always recommended that you have to take a backup of the code. So single user instance is okay, but what about a multi-user instance? So if 5-6 people are working on a project, and there will be situations like if we given an opportunity for everybody to delete the code from the central repository, maybe unknowingly if somebody has to delete their own code from the central repository, they might be deleting somebody else's code from the central repository, and they might be overwriting, they might be creating the same data flows with the same names, and that will be overwriting the content in the central repository. So to avoid all these things, we need a concept of secure central repository, authentications, and restrictions. So we'll be looking at authentications, restrictions, and how we create groups in central repository, how we create authentications and restrictions in central repository, and what are the different things that we can see within a central repository, the maximum things that are possible with the central repository. We'll look at them now. So yesterday, if you remember, when we are creating a secure, non-secure central repository, I'm taking you to the navigation where we created the central repository, to the repository manager. Alright, so when we are creating a central repository, this enable security was not grayed out, it was available, but we did not check that. And you remember, when we are trying to upload that into the central repository, using the management console, it was throwing an error saying that non-secure central repositories cannot be part of the management console. So we'll make that into a secure central repository, and for that I had to give the same credentials what we have given yesterday. Alright, so now get version to see this non-secure central repository is available. So now check on enable security and click on upgrade. So I'm giving all the earlier credentials that I have given for this repository. I'm checking on enable security and click on upgrade. So now this repository will be upgraded, and it will be upgraded into a secure central repository. So now if you see, a security key is generated at this following path, so which you can use in case you want to use that as a secure key. What generally happens is when you are creating a secure central repository, this secure key will be generated and it will be placed in this configuration file of your system. Okay, so what they will do is these people admins will send this .key file to all the users, so that if they want to have an admin access, they can take this key and add it in the central repository. I'll show you how to do that, and then they can have the admin access. And for the junior developers, they don't want to share this key, so they will not share, so that they will have some restrictions on the central repository. They cannot do all the activities like delete and compare so they cannot do that. So this is one security key that will be generated, and now you see get version, you see a secure central repository of version so and so is available on the system. Now it is a secure central repository. So let's close this, and now go to the management console. Alright, so management console, and the next important thing that we need to do is register the central repository in the management console, so that you can view all the list of secure central repositories under the central repositories tab of the management console. So now if you notice our repository is not present, so let us add a repository. So expand the management, connect to the repositories, drag down and click on add button here. So here you need to give the database name, the server name, and the database name. You need to give. So copying it from the SQL server. Yep, we have it here, the database name, then the username and password, and I call it as central_repo_morning1. Okay, so this is a central repository for the morning batch, so I'm calling it as central_repo_morning1. Now click on test to see if all the credentials that you have provided are correct or not. So if these credentials are good, you can click on apply. So earlier when we clicked on apply, through an error saying that you cannot add a non-secure central repository to the management console. So now we have created that into a secure central repository. Now let us see. It did not throw any error, and our repository central repo morning1, which is a secure central repository which is created on SQL Server. This is the server name, this is the database name, and this is the username. So this one is now added to the central added to the list of repositories. And if you expand the central repository, now you can see, you should be able to see the repository, right? Our repository is present here. Now we have created a secure central repository going to the repository manager. We just upgraded the existing non-secure central repository and made that into a secure central repository, and on top of that we added that to the management console, and now we are able to see this repository in the management console. Alright, so next step is to create users and groups. Now we created a secure central repository, we added that to the management console. The third step is we have to create users and groups. So to create users and groups, click on this tab here, users and groups, and now we have the users tab and the groups tab, right? So let us do it from the lower level, or you can do it even from the top level as well. Create groups now. So we are creating a group like admin and apply. Now create one more group, developers, apply. So now I've created two groups. One is the admin group who needs every access on the repository, like he wants to delete, he wants to create, he can do that. So it is a complete admin activity. And the second one is the developer. So let us create the users. Now I will create two users, user 1, I think, yeah, and the password also I'm giving user 1, and confirm password, display name, and the status is like active or suspended. keep it active, and you can choose which group this member can become. So he's a member of the admin group. You can choose it from the default group drop down here, or what you can do is you can remove groups, or okay, so you can remove this group. Okay, that was made a default group, so you can add any groups or you can delete these groups. Okay, so click on apply. I made this DI group is the default group that will be present in the system, and I made user one as a member of the admin group. Click on apply. Now create another user. Let me create user 2. Okay, I'm giving the same password here, user 2. Display name as user 2. So this will be the general admin activity. So you can give some description like this member belongs to the developers group, and I will remove him from the DI group, so it's just a part of the developer group. Click on apply. So now you have your groups, and if you look at admin, user 1 is the part of this one. Let's go back and look at the developer. User 2 is part of your group. Now we have created the users and groups, so based on that we have given authorizations and restrictions on the users. Now the next step is we need to go to the central repository and configure the secure central repository. Until now it is a non-secure central repository. Now you see the security as no, and it is just a cube symbol. Now let me deactivate this first, and let me edit this one. Enable security checkbox activates the repository user information. So earlier a key was generated, so you can read that security keys by clicking on this, and you can see the keys, all the keys here. So I think, yeah, this is the key that was generated by us. Or you can, if you get any confusion, you can go to the details and you just click on the date modified. It will give the latest one on the top. So this is the latest key that was generated. You can either read that key from there, or you can give the repository information like user 2 and the password as user 2. Click on OK. Okay, invalid repository name, spelling mistake I guess, user 2 and user 2. Alright, now it is added, and if you see, it is a secure central repository. Earlier it used to be no here, now it is turned to S. And now activate this one. It will ask you for the password if you don't click on remember checkbox here. I'm not clicking on that because I want to show you the differences between the admin and the developers. Now this guy is a part of the developer group. You have a drop down here, you can see this guy is a part of the developer group, and you just look at his permissions. He has only the read permission on the code, right? So he just has read permissions. And looking at the options, now if you see, the delete button is disabled, the permissions is disabled. You can just get the latest version of the code. You can get by label, and you can get show the history. I mean, you can see the history of this particular job, but you cannot do a check-in, you cannot do a checkout, or you cannot do an undo checkout. You cannot do a labeling on, you cannot do a permissioning, you cannot do deletion, right? So this, why do we need to create some users like this? Because when you are doing the testing part of the project, you need some developers who can just execute the code. So that is what we call as like code promotions. We need to promote the code from the development environment to the testing environment. So let the testing environment be any. So you'll have a quality testing, you will have a PUT testing, or you have a user UATs, you have mocks, you have mock 1s, mock 2s, and you have DSTs, data string testing. So multiple sorts of testings can be a part of your project. So at these stages of the project, you need some developer who just can execute the job. He can get the latest version from the central repository and he can execute the job, because we don't want him to do any changes on the code. So if there are some changes that has to be done, that are the defects that are identified at this stage of the project, what we need to do is, like, this tester who is testing the code should raise a defect, and this defect has to be assigned to the code developer, so that the code developer will get a email notification saying that there can be any defect tools. They can use a HPQC, they can use a Lotus Notes, so they can raise a ticket and say that this particular job was developed by so-and-so user and this is the defect on this job. So please rectify this defect. So that will be assigned to the user, and the user will start working, or the developer will start working on that particular defect. And once this defect is resolved, he will upload the code into the central repository by doing a checkout first, and then checkout without objects and dependents, and then he will rectify the code within the local repository, and then he will do a check-in from the central repository. So after that, this code will be uploaded to the central repository, and he will send a mail to the tester saying that I have made the changes and I have uploaded the code into the central repository, and that guy again promotes the code from central of the development to the central of the quality environment, and then he will do a testing once again, and if the defect is fixed, or if the resolution is proper, then if he is not getting that error again, then he will close the defect. So that will be the general process. And now let us go and create user 1 and see the difference. We have added user 2 as the user here. So for that, now you see a different icon with a lock symbol on the central repository, which says that this is a secure central repository. I deactivated that. Now click on edit, give the user 1 here, and click on OK. Activate this one. Okay. Now click on the central repository. Now this guy, even though he is a part of admin group, he has just read access, but you see this guy is part of 2 groups, DI group, and you have a full access on top of this. So you can either delete, you can give a permission, you can give a checkout, check-in, get latest version, get label, or compare. So you can do all the activities, because this guy, user 1, is also a part of the DI group. So you can create these groups, and you can give authorizations and restrictions, and you can change in the mode of the permission that you provide to the users, just to ensure that, you know, this is how we do it. So all the team leads and the administrators, they get a full permission, because these guys have already worked on the projects and they know what has to be done, and they feel quite responsible. And for the developers, what generally we do is, like, we give them a read permission, and whenever they have an issue, they want to delete something from the central repository, or they want to do some changes on the central repository, we ask them to send us an email so that they can approach us for this help, and we will do it on their behalf, right? We as developers, as administrators, we can have an access for anything in the central repository. So if some user is having some problem, no, alright, so if some user is having some problem, we will ask him to approach us, and we will do a deletion or whatever the changes that is required by him in the central repository. This is to ensure that the system is safe and nobody can do a malpractice on the system, or not even by mistakenly. We don't want somebody to delete the code which was having a more complex logic and which was approved by the quality check and which is ready for the production. So to keep things safe, we need to give these permissions and restrictions. And one more most important thing I'll show you now. This is I bet you this you will not know unless you will be working on the projects for at least like 4 to 5 years. This is called the code promotions. So I'll tell you how the code moves across the environments. So this is one of the most important thing. As a senior guy, the client will expect you to know. We have a question coming here. Yeah, DI stands for data integrator, Rishabh, because this thing, this data services is an upgradation of data integrator. So there are so many things within the data services which you see as DI, which stands for data integrator. In the one just we have seen in DI group, so it is the data integrator group. All right, so okay, all right. So now next thing. So if you look at the project, we have a developer environment, we have a quality, we have a mock 1, a mock 2, and finally, let us assume this is a go live. So now you have a developer here, 2 developers who designed this code and uploaded them into the central repository. Okay, now just give me a second. Now, this guy has designed his code, updated that in the development central repository. Good. Now, how do we move the code from one repository to the another repository? How do we do the code promotions? So we have one more question coming up. As to send the code to the another developer without going through the central repository, how does this happen? Yeah, Rishabh, that's the next question that I'm going to answer. Without uploading the code, that is a very good question, Rishabh. So without uploading the code to the central repository, there are 2 other ways in which we can send the code to the other users. Sorry. Sorry for my bad throat. So, yep, once we are done with this concept, I'm going to show it, Rishabh. We'll see how we will send the code to the other developers without doing an upload into the central repository. Once we are done with this, all right. So now user 1 and user 2 created their codes and uploaded that into the central repository, and we did a quality check on this one, and now we have to send it from this central repository to the another central repository. So how are we going to do that? So we cannot directly push the code from one central repository to another central repository. You don't have any option here. All right, you don't have any option to do a push into another central repository. So what we will be doing in a general scenario is we create an intermediate repository and we get the final code from the developer central repository into the intermediate repository, and then we upload that into the central repository of the quality system. Okay, so we'll create a dummy repository in between, and on top of that we just get the latest version from the developer's central repository and upload that into this one, the quality central repository. Because if you remember, I told you we can have more than one central repositories, and I guess this is a question from Rishabh. So we have more than one central repository is configured to the designer, but only one central repository can be active. So we can switch between the central repositories. So first I create a dummy local repository, intermediate local repository, and I configure and activate the development central repository on that, and I get the latest code from that one, and then I configure and activate the quality local repository, and I upload the code from my local repository to the quality central repository, and then the tester will connect to the central repository of the quality system, and he will do a testing. So the process, what we are trying to do here, this one is called a code promotion. You are promoting the code from one repository or one environment to the another environment. Similarly, these guys, once they do a testing, we create one more repository, intermediate repository. So trust me, I have learned this concept after working for 4 years in Bureau. I got an opportunity to know about this, because you know, the way it goes, they'll never give you an access, or even though you are an architect, even though you are a project manager, or even though you are a team lead, they will not allow us to, have a peep into the system, because everybody is conscious about their roles and responsibilities, and they want to keep them safe so that their market will prevail. So I took 4 years to know this concept. Okay, so now there will be another intermediate local repository, and they upload that into the mock environment. And again, a tester will connect from mock environment, download the code, and execute it on the testing system. Similarly, it goes on for this one. Or there is one more thing that we'll be looking at, the data store configurations a little later. Yeah, this is the concept, data store configurations. Using those data store configurations, rather than moving the code across the repositories, what we can do is we can execute the code. Being on one system, we can choose on which system we want to execute the code. Even on, if at the time of execution, you can choose you want to execute the code on a DSD system, or you want to execute the code on a mock system, or you want to execute the code on a development system. So you can choose like which one. So this part is called the data store configurations. Okay, so we can configure the data stores of our system to decide, or at the time of execution, which one we want to execute. So this is one way where we can deploy the code on different systems, and this is another way where we deploy the code by creating. So in this first process, the code actually moves from one system to another system. And in this second process, we'll not move the code. We'll just keep the system, we'll keep the code wherever it is developed, and we will point it at the time of execution. So at one point, it goes on to the DCT. At the second point, it goes to the mock, and third point, it goes to the production system. So we can choose at the time of execution which system it has to get executed. By local repository, you can virtual hypothetical repository. Yeah, we have a question by the intermediate local repository. What I am mentioning here. So is that a virtual or a hypothetical repository? It is just a local repository as you create on your system, but you will not execute the code from there. And that means you will not register this local repository onto the management console, because you're not executing any code here, or you'll not register this local repository on the job server. You just create it so that you can move the code from the central repository of one environment to the central repository of another environment. Is that clear, Rishabh? This repository which we create as an intermediate repository will not register that in the management console. Will not register that on the job server, because we are not doing any executions on that local repository. Yeah, so the testers, so that is what I am saying. The second group that we have created as user 2, he just have a read permission, and this user 2 who just have a read permission will do a get latest version of object from the central repository to his local repository, and then he configures the second central repository and he adds his code to the central repository. That's it. So he will not have any access like delete access or create access. This user for this intermediate repositories, or what we call it as DCT users, or we call this as testers. So these testers will have only a read permission. They'll not have any full permissions. They just have a permission to move the code. All right, so that's good. Good questions, Rishabh. Keep going. So now, this is one environment. And the second thing, we'll look at these data store configurations a little later. So this is, we know how to do that. And the second thing, what Rishabh was asking is there a way that can we push our code from the local repository without sending it to the central repository? Is there a way that we can send it to another person? Yes, there is a way. And the way is select the job, right click, and go for export. Okay, now it shows all the data flows, data stores and all. So generally, do remember this is one of the best practice that we follow. Sometimes we might have an old repository credentials and some of the user might have the latest repository credentials, or this is the development environment and you have the development data store environment configurations here. And now in the mock environment or in the final go live environment they want to import your code into the system. So your credentials, which are the development credentials, will overwrite the production credentials. So we don't want to do that. So what we do is we just exclude the data stores. So there are two types of exclude. You exclude the entire tree. All the tables will be gone. So you include the entire tree, all the tables and data store will be present. You just exclude the data store so that this entire structures will go, but only the data stores will not go. Means the configurations which you will be creating within these data stores will not be pushed onto the another system. So these configurations will not be pushed onto the another system. Whatever the configurations that they have, they will be active. And the second most important thing that you need to remember is the naming convention. The names of the data stores that you have on your system should be the same as the names of the data stores that the other guy is having on his system. So now you export the code by selecting the code, right click and export, right? And you have excluded the data stores, and if you have any file formats it will show the functions, the transformations to export. And now once it is done, you just click on export. Okay, you can clear all if you don't want anything to be present here. If you have chosen some wrong code by mistake, so you can do right click and clear all. Okay, now let us export some other job, so which has a flat file as well. So now you can see a flat file here. Now I exclude the data store. That is the best practice that we follow. And second most important thing is now export. You have two options here. One is you export that directly into your colleague's repository if you know his repository database name and the repository server name. Okay, so if I know that this code is going to be pushed into the same servers, and I know that the second user is also present, so I can give the same server name here. Okay, and db underscore user 2. Okay, and this is username 1 and password. So I can do this way, either push the code directly into the second user. So just click on next, and it will ask you whether you want to create all these things or you want to exclude, because the data stores, if they are already present, it will say that these things are already present. So if you want to create or exclude, so I can choose like I want to create them because they are not present, and if they are present, it says they are existing, so I can exclude them. So just click on next and yep, finish. Now this code is pushed into that particular user 2, db underscore user 2. So let me take you to that one and show it to you. So this is ff underscore SQL job, data services designer, db underscore user 2. I think I have created this user 2 repository as for the just a brush up session for the ship. So now this job is present in this particular repository. And now if you just click on export and see the contents, okay, so I did not send the data store, so the data store is empty here because it did not create any data stores here, and this flat file is present, the tables are present, and everything is present. Screen hang, guys, can you please confirm if you can see my screen, because I just got a message from Rishabh saying that his screen is stuck and he cannot see what the changes that I am doing on the system. Can you guys, Vaishali, Gopal, can you confirm if you can see my screen? We are in DB_user2 screen now. Alright, Rishabh, so I repeat that once. So once you go into this job, on the previous repository or in the current repository? Okay, just remember this is, okay, it got jumped. Alright, so I'll just repeat this once again, what we are trying to do. I'm trying to push the code directly into another repository. So now let us assume that you are in user1 repository, and this user1 wants to send the code to this user1 wants to send the code from his from his local repository to user2, and let us take this job. So I just click on export, and I'm not excluding the data stores. So right click on job. Guys, I think you can see my screen. Right click on the job, export, view the repository credentials, okay, username, password, and click on next. And the system will ask if this data stores are table or whatever it is that are used in the job are already existing or not, and if you want to create or exclude this thing, you get an option to choose. You want to create or exclude. So click on next, finish, and now these 13 jobs or 13 objects are moved into the second repository. So now remember, we are in user1 repository here, db_user1. So now let me take you to user2 into which we could push the code. So log into the designer. So user2 is the second user. So click on OK. And now if you go into the jobs and see, the second job is also available, and this time we did not exclude the data stores, so the data stores were also created. So this is how, this is one way how you can push the job directly from your local repository into the second user's local repository without touching the central repository. This is way one. So in this, what we are trying to do is, we have local user 1 and local user 2. So we have a central repository. The general approach is we upload the code to the central repository and download. But here, without going to the central repository, we are directly pushing the code from one user to the other user. This is way one. The second way that we can do is, right, let me take you back to the user 1 repository. Okay. The second one is, I'll show you graphically what we are trying to do. The second one that we need to do here is export the code as a file, okay, as a file on your desktop. Export your code or group of jobs as, one second, as a file on your desktop, and read the same file into the user studio. So this file is called as an ATL file. You can export the job as an job name.atl file, and these ATL files, ATL does not have any name here, it is just an extension. Quick question on dummy repository method. Yes, Jay, go ahead. Yeah, Jay, you can ask me a question.
How would you make it for both available for both repositories or like both systems?
Sorry?
Like, you know, so we are creating like intermediate repository. So how can you make it available on both systems, like for the developer system or and UAT system?
All right. So you go to the designer, go to tools, go to central repositories. Now you can click on add and give development underscore central repo. Okay, you view those particular repository names here, the server name, database name, username, and password. Click on OK, and you can see multiple repositories present here. Let me add one more repository, which is a central repository. So dbus underscore central is my central repository here, which is a central repository that I have created for another batch. So I'm going to add that repository into the system. us underscore central underscore repo. The database name is this one. The database server name. Oops, no. SA. Alright, click on OK. Unable to connect to the repository, a non-secure central repository. Okay, it is a secure central repository. Now let us go to the management console and see repository US Central, the users that are present here. Okay, user 1. Okay, right. Let me use user 1 and user 1 here. Click on OK, and now I have two repositories present here. Okay, Rishabh, I'll just do it a little slow. If you have a problem, do let me know. Maybe the screen refresh rate sometimes it gets bad because of the jam that we have on this network. So sometimes it goes bad for some of the people. So I do understand that. So now what we are trying to do is I'm trying to add one more central repository which is not a part of us, which we did not create. So this I'm activating this. Okay, I'm activating that with the username as user1. Now if you look at this, so it has not many jobs, okay, which we do not do. And US corporate training, there are so many jobs, and you want to get all these jobs into your local repository. Right click, check version. So now this is how it goes. So as per Jay's question, we can have multiple repositories configured, central repository configured within local repository, and we can switch between the repositories. Like if you want to activate some other repository, first you connect to the development repository, central repository, get the latest code from them, and then you configure and activate this one, the second repository, which is a quality repository, and now you test the jobs and you upload them into the quality repository. So this is how it works. All right. So I think Jay, did I answer your question?
Yes, thanks for that.
All right. Yeah, that's good. That's good. Okay. So that is one way. And the second one that we are looking at is an ATL part. So we export the code as an ATL file, and the other person, you send it to the other person through an email or through a pen drive or through a flash drive, or put it in some common place where he can copy that one and he can copy it back into the system. And that is how we call this as ATL backups. So ATL does not have any extension, full form for that, because in the beginning, business objects and ATL organizations were partners, so the jobs were named after that company's partnership .atl. If it is business objects enterprise, you might have heard about BIAR files, so business intelligence archive resource files. So they have some extensions, but these ATLs does not have any extension. It is just an ATL. Now let us see how do we take a backup of the entire project, right? So we have created a backup of this project. Now some of you raised the request for me to send all these jobs to you so that you can import them into the repository, as I can do. Right click on the entire project, export, sorry, So now all the jobs are present. Cross-check all the jobs that you're sending, all the data stores, right, and all the flat files. Now right-click, export, and now you have an option here, export to file. You can either choose an ATL file or you want to export it as an XML file. You can do both. You can either choose as extension as .etl or .xml. I'm creating that on the desktop, so I will call this as morning training. I just click on save and finish. So all these 33 objects are exported to the desktop. I'll take you to the desktop, and now you can see a morning_training.atl file on the system. Now let us go back to the user 2 to import those ATL files so that you can see the jobs. Rishabh, I'm going and logging into the second user. So till now we are in the user 1, db_user 1. To import these jobs which we have exported now. Alright, just give me a second. I'll sign out my Skype. Okay. Alright, now we don't have a project, we have only 2 jobs here. Now I want to read those jobs which I exported from the repository 1. Okay, I'm going to read these jobs which I exported from repository 1 into the repository 2. So we have a question coming up here. On a typical project, do you usually have one big project with multiple workflows or smaller multi-projects with their own multiple workflows? Yeah, this is how it works. So if it is a very big project, then definitely we segregate them into different categories like finance category, sales and distribution category, material master category, vendor master category, custom master category, and then we divide that big category into multiple substreams, and then we create each and every substream into a job, so that we create this workflows. I mean, you are asking me on a journal terminology. So workflows, yeah, we create these multiple groups into a single group called a project, and at the final stage we consolidate all these projects into a single one. Is that clear, Rishabh? Okay, that's good. Right, so guys, I'm learning a lot from you as well, so it is not just I'm teaching and you are learning, it's vice versa as well. So right, so now we have import the code which we have exported from db_user1 repository. So now we are trying to import this one into db_user2 repository. So we have an option in the quick start page saying that import from file. Click on that, select the ATL file, click on open, and it will give you a warning saying that it will take a long time to import all these jobs. Now you go to the project is available, project DODS_training, which is actually created in db_user1, which is not at all created in db_user2, but I was able to copy that back into the db_user2. So these are the 3 ways that we move the code. So one is you export that into the central repository. The second one is you export that directly into the local repository of another user. And the third one is export it as an ATL file or an XML file and ask the second person to import that. So generally in a project what we will have is we will have an outbound directory where we have to do this sort of activities. We want to push the code as an ATL file into that outbound directory so that the other guys who wants to import that particular code can import them from the from the outbound directory and build their own jobs on top of this one. Okay, this is one way what we can do, and this concludes everything about the central repository, secure central repository. So I can just color this as the normal one because we covered the single user instance, multi-user instance, how to export the code, how to import the code, and even without touching the central repository, how to migrate the code between the local repositories. We have seen that. And now let us go into the platform transformations. Okay, so before we go into that, do we have any questions on the central repository concept? Somebody is not clear about it and wants me to repeat that one. I'm glad to do that. Any questions? And guys, if you are facing any interviews, just talk more about the central repository, because these are the 100% things that we can do within a central repository. And you just tell them that we have done this, and so on the things, and this is the strategy that we used in our project. Just tell them that it is a strategy local to your project. So they have to accept you for this knowledge on the central repository at least, because generally they don't get the people who work on the central repository, because that is an administrative task, and for an admin task for the people to know about this, it will take so many years of rigorous project experience. So just request you to talk about these, prepare well and talk about the central repositories and how you created the users, how you moved the code between the repositories and all this stuff. You just talk about it. That will crack the interviews. And the next one that we'll be looking at is the transformation. So now we are going into a little more deeper sets of the data services. So let me log back into our local repository, which is db_user1. Okay, so welcome back to our local repository db_user1. Alright, so we have our projects, repositories, jobs, everything available. Now go to the transformation tab, and now you have one set of transformations called platform transformations. And if you look at these transformations, you have a set of 6 or 7 transformations. Just let me check. Alright, you have a set of 7 transformations present here, these 7. So we'll be looking at these transformations now. So these are called the platform transformations of the data services. So the platform itself says that these are the basic transformations of data services. And what I suggest you is, if you know in and out about these platform transformations, you guys will be ready to work on any migration project. Because when you look at the SAP best practices, the jobs that are developed by SAP, the sample codes that are provided by SAP, if you look at them, these will be the transformations that are used in the code. They'll not use any other integrated transformations, or they'll not use any other quality transformation. They just use the platform transformations, and these are the most important transformations of data services. So I repeat, if you know about these transformations in and out, and you are ready, or you are like well versed with these transformations, how to use them, when to use them, and what are the different scenarios that we can use them, then definitely you can start working on any migration project across the globe. Because anything can be done only using these 7 transformations within BODs. And these are very simple. Okay, I'll show you them. These are very simple transformations, very easy to use transformations. Alright, so now we will be looking at these transformations one by one. So now let me open a notepad for this. Now first one is a case transformation. Okay, so what is a case transformation and when we need to do this? So for example, I have data from different regions. Alright, I have the data from different regions, and now I want to apply the taxation on the code, taxation on the data, so that I cannot apply a single taxation from different regions. So I had to break the data into different regions and then apply the taxation code on that, and again merge it back into a single data set, so that the data, the taxation is applied or as per the respective regions. So you understood the concept. This is what we are trying to do. You have a data from different regions, and now you have to apply the taxation on top of that. So based on the different region, you have to apply different taxation on that. So what you need to do is, first one is split the single data set into multiple data sets based on the regions, apply the taxation codes on all the data sets, and then combine that back into a single data set. So now with this example, we will be looking at two transformations called case and merge. Okay, so the definition of a case transformation is split a single data set into multiple data set using a valid business logic, and merge transformation definition is combine various data sets combine multiple data sets into a single data set, provided the metadata of all the source data sets is same. So I'll show you what is that metadata and all. Don't get confused. So now let us create a job. So right click, go for a new bad job, create a job, call it as job underscore case underscore merge. So I created a job, job underscore case underscore merge. Now create a data flow, df underscore case. Now we will have a look at the data. Now I have one source table. Okay, so now let us take the orders and view data. So now if you look at the orders table, there are different values for this shipping region, shipping via. So if I filter on this one, okay, so shipping via is not equal to 1, apply. So now see values 2 and 3, and let me filter on this one, also saying that shipping via is not equal to 3, apply. So there is only one more value, which is 2. So there are 3 values in the data which says that the shipping via is 1, shipping via is 2, and shipping via is 3. Now I'm clicking on this button, remove filter. Just refresh. I applied filter to see on the data what sort of data we have. Now let us assume that we have a requirement that we need to break the data as per the shipping region or shipping via. Now we have to split this orders data into 3 data sets. Okay, so now I make these orders as in the source table. I'm dragging it from the data store. Now go to the transformations. Alright, use the case transformation, drag and drop it within your data flow and connect it back to the source table. So what I did, I dragged the source table from the data store tab, I selected the orders table, I dragged it here, then I went to the transformations tab, I selected the case transformation, dragged it here, and now let us first complete the structure of the job. So this is how we need to do in a project, because they will ask you to foresee what you will be doing. And okay, so one second, via 1, via 2, and via 3. Okay, so this is how your developments will work in a project. So these projects, when you are assigned to a project, they want you to understand what you are going to do before you start building the job. So they'll give you the functional spec. On some projects they follow this one because they want to ensure that the developer knows each and everything what he's trying to do. So what they will do is they will take the functional spec and give it to the developer and ask the developer to write a technical spec himself, because a technical spec is nothing but a pseudocode that a developer writes. So this guy writes a code saying that, okay, these are the tables that I'm using, these are the jobs that I'm creating, these are the data flows that I'm creating, and this is what I'm going to do within each and every job. So this guy has to define what he's trying to do in his technical spec. So we have to foresee what we are trying to do. So that is one of the best concepts as per the migration job building. So you have to remember remember that you have to foresee what you're trying to do. So in our logic here, we are trying to split the data into different sets based on a valid business reason. So if you look at the definition, it says that defines the process of different rows in different manner. So if you convert that into a simple English, it says that it splits a single data set into multiple data sets. Even looking at the graphical representation of case transformation, you can easily understand that the case transformation splits a single data set into a multiple data sets based on the business logic. Okay, now you remember one thing: if we split a single data set into multiple data set, these metadata structures of whatever the single data set that we have here, this is the metadata, the table name, the column names, columns, and the data types and their lengths. So these metadata will remain same on all the target tables. So because we are splitting a single data set into multiple data set, so you need to remember that when you are doing a case transformation, the output tables have the same structure as your input tables. Alright, so now open the case transformation by clicking on that, and now you see the schema where you have all the columns present. Okay, you have all the columns present here, and at the bottom you have a tab called case. Right, let me highlight that one. You have a tab called case, and you have three checkboxes, and we'll talk about this a little later. We have an add button, we have a labeling area, and we have a functions tab. So these are the different regions of a case transformation. So now let us talk about the first one. Produce the default output with the label as default. So what the system says that if you are applying a valid condition on the data and you are taking that data into different tables, and what about the data that is not a part of your valid condition? You should not skip that data because you are losing those records here. So these records which are not a part of your condition will be produced with an output as default as a label. So you can choose this one, or you can rename this one as remaining, or whatever it is. And the second condition is a row can be true for only one case. For example, if you are doing two case operations on one table, okay, so let us go and do this. So we are performing two case transformations on one table, and a row can be true only for one case. Okay, so it cannot be true for two cases, because if it is true for two cases, the same duplicate record is pushed into the table 1. So this should not happen. So a row can be valid for only one case. And the third one is preserve the expression order. So if you are giving some expressions here, so you want to preserve that, you can check this box to preserve the expression order. And the tricky part is, like, you want to add an expression, you can either click on this add button. You want to delete an expression, you can delete that, or right click on this gray part and click on add expression. So you need to give a label here via 1. And now once I press on tab, this throws an error saying that no valid reason is provided here. So I select the column shift via from the schema, drag and drop it into this one, and give the value as 1. And again click back on the expression. Now the red mark or the cross error symbol is gone, which says that this is a valid expression. So you want to validate that one, you can just validate on this one. It is good. Now click on add expression, give the label as via 2, and now it again throws an error. Select the via 2, drag and drop it here, and give the value as 2. Now we know that data has only 3 vias: via 1, ship via 1, ship via 2, and ship via 3. So the default values, I'm not doing a case of that, I am converting that as via 3 because I know the data, and I am putting as via 3. Now connect this case to table 1, and it gives you the labels via 1, via 2, or via 3. It is via 1. Connected to the table 2, it is via 2. And connected to the table 3, it is via 3. Alright, now we have the data. spread across, the case logic built. We have a single data of table. Now, if you look at the metadata of all the three tables, it's the same structure as the source table. The same number of columns, the same data types and their lengths. Alright, so now let us execute this job. A single data set is split into multiple data sets based on the condition that you have provided. Now you see the single data set has 830 records. To via 1, 249 records are gone. Via 2, 326 records are gone. And via 3, 55 records are gone. Again, look at the time. It has done all these things in less than a second, less than 0.1 seconds to be more precise. And the entire job took 2 seconds to complete. And now if you look at the data, you have the shipping via as 1. So let me apply a filter to see if there is any other value other than 1 in this table. So I'm giving ship via not equal to 1. Apply and OK. So we are applying a filter to see the data. Click on refresh. We don't see any data because only ship via 1 is present on the table. Similarly, cross-check ship via 2 and cross-check ship via 3. Only the region 3 is present here. Okay. Now you have done a split on the data using a case transformation that you broke a single data set into multiple data set, but you know the condition. Whatever the source structure is present, the target tables also have the same structure. All right. Now let us do a merge transformation on top of these three tables. Okay. So the prerequisite for a merge transformation is that all the source tables, now these are the target tables. In the next data flow we'll make them as source tables. The prerequisite for a merge transformation is all the source tables needs to have the same metadata. Alright, so now let us go to this job, create one more data flow, df underscore merge. Okay, there can be a quick question here saying that what if we need to join different tables but they don't have the same metadata. Alright, what we can do is we can use a query transformation in between to change the column names or select the common columns between all the tables. We can do that. We can add one query transformation just in case you know that this is data coming from Oracle and they have different naming convention. So you want to change the order ID to ORD ID, which is common in the other table. Double click on the column ORD ID and change the data type or length to whatever the value that matches with other tables. Okay, so that all these tables will merge, and this is one of the best transformations that I like in the data services. So select the merge transformation, drag and drop it, and connect it with all the tables. And there is absolutely nothing that we have to do when we are using a merge transformation. It merges all the data sets in a single data set. Okay, the main requirement is the data types and their length should remain the same, and the metadata of each and every table of your source should be equal or should be the same. So now what merge does is it merges all the different tables into a single data set, and now I call it as stage underscore merge. Target data store. Save this one. Now execute the job once again. Now I define the order of execution here. First I want the case to be executed, then I connected that to the merge statement, merge data flow, so that first case get executed, it splits the data into multiple data set, and again the merge will execute and it will combine the multiple data sets into a single data set. So if you look at the trace of the job, df case is executed first, then once the df case is completed, df merge is started, and once this df underscore merge is completed successfully, the job underscore case underscore merge is completed. And if you look at the monitor, you can see some of these records are split from 830 records, these 249, 326 and 3225 were split. And now after the merge transformation to the stage and the square merge table, 830 records are pushed from all these three different tables, and now they are combined into a single table. So that is what the count that we have in the orders table, 830 records. So now let us go here. You see the count of records 830, or you click on the next tab, this is a precise tab of table, and click on the number of records, and you get 830 records that are present in the table. So this is how we use the case and merge transformation. Generally, these transformations will be used as a combination within your projects. So if you want to split the data based on a particular logic, so that you can do some analysis on that, or you can apply some business rules on that, and again you club them back into a single data set using the merge transformation. So is this case and merge clear, guys, so that we can go ahead with the next transformation? So guys able to understand this case and merge transformation? Gopal, Vaishali, Rishabh, Jairam, is this clear? Okay, does the source table in the merge has the same metadata? Exactly, they have to, they should have the same metadata. If not, the merge will throw an error saying that one of the source tables does not have the same metadata as the other source table. So in that case, what you can do is you can use a query transformation here. Just for example, this via is not correct. So via one has different metadata compared to the other two tables. What you can do is you can use a query transformation in between, change the names and data types so that these match the second tables, and then you merge them. So the meaning of merge is like you have the same data sets available, you are merging them into a single data set. So if the namings are different on the metadata, yeah, it is like union on the SQL. That is correct, Jay. It is a union on the SQL. So we have one more question from steps in case again, please. Yeah, we have a question from Rishabh. Rishabh wants to see once again the steps that we do within the case transformation. So what we need to do is go to the case transformation and click on the case transformation. Now you see the schema, the case tab, and the expressions here. So we have to right click here, go for an add expression, or click on the add button here. Okay, so these will add an expression here. So we give a label for that. Okay, and once we give a label and click on the expression, it will give an error saying that no valid expression is given here. So select the shift via column on the schema, drag and drop it into the case, and give a value like 223, which is not a part. I'm just creating a dummy label for you. Okay, now again click back on the expression. It will say that syntactically it is correct, so the error icon is gone. Go back, create a template table, call it with the label name via 223 or whatever it is. Save it in your target data store. Now connect it to the case transformation, and now you see the label 223 available here, and map it. Okay, so Rishabh, I think, is this clear what we need to do within the case transformation? Rishabh, can you confirm? Yes, yeah, good. So we have one more question coming from Jay. That is a very valid question. Is it possible to have a single target with multiple case conditions? Yes and no. That is the answer. Because yes, because there will be project scenarios where you'll have a single target table, and based on the different logic, you have to push the data into the target table either as an insert, either as an update, or either as a delete into the target table. For that, we have the next transformation that we are looking at. So that is the reason why I said yes. And using the case transformation, you cannot push the data into the target table. Case is used to split a single data set into multiple data sets. So that is the reason I said no. So using one more transformation, we can take the different data sets as inserts, updates, and deletes into the target table and push them using this one. And using case, we can only split a single data set into a multiple data set. Is that clear, Jay? All right, perfect. Welcome. Okay, any more questions before we go to the next transformation on case and merge? Very simple. Case is used to split the data from one single set into multiple data set based on a business logic. Like, for example, you are taking, let us take the data from India, telephone data from India, and we want to split that into 4 regions, northeast and southwest. So what we do is we apply a filter, or we apply a case statement on the data saying that split the data into north, split the data into, all right, yeah, okay, Rishabh, I'll call it a day once I explain this. All right. So now what we can do is we can split the data into different data sets using a case transformation, saying that this is the data from north, this is the data from south, this is the data from east, and this is the data from west. And once we do some analysis on the data, now we want to combine them into a single data set. So that is the reason why we do a merge on top of that again. Right. So guys, you have patience because I think Rishabh is already out. He says that can we stop for today? All right, so I don't want to overdump you guys with more and more things on the same day. So I think we'll call it a day now. And what we will do is we will today evening I'll be traveling again. So tomorrow morning I will reach Bangalore again at 7:30 or 8 in the morning. So we'll not have a class tomorrow morning. Again, on day after tomorrow, we'll have a class. Hello? All right, so tomorrow morning, my time, which is like a Sunday night for you guys in US, you don't have a class. Again, on Monday night, you have a class. So that will be Tuesday morning for us. Yeah, Gopal, ask me a question.
So what is the theoretical definition of a repository?
Repository are of 2 types. The repository is used to save the information. Okay, Gopal, just a second, I'll put you on mute. Okay, right, good. So the theoretical definition of a repository is a storage place for a user. So each and every user will have his local repository. So that is a storage place where he saves all the tables that are related, or all the credentials, or all the transformations that are related to his job, or whatever the jobs that he generates, he saves them within the local repository. So that is one definition of repository. The second definition of a repository, which is a central repository, is a central repository is a place again used to do the storage. So repository means a place where you store. If it is a local repository, you store your jobs that you have in your local system, and if it is a central repository, all the developers upload their code into the central repository and save that. So the definition, again I repeat, the repositories are storage locations. Based on the type of repository that you are using, it differs. So Gopal is, Venugopal, is my answer okay to you? Is that clear? Alright, so perfect. So tomorrow morning, guys in India, we don't have a class, and guys in US, Sunday night you don't have a class. We'll catch up again on Monday night. So do practice. Yeah.
Hi, Samuel. This is Jay.
Yeah, Jay.
I think, is it possible to take backup classes, like even I didn't attend first few class?
Oh yeah, we can do that. So what we can do is we can take that backup class on Monday, Monday night my time, because I'll be reaching there by 8 o'clock in the morning. So I'll go to office, and once I'm back, I'll talk to Prakash, and I'll ask him to give you a call, so that we can schedule some particular time, and we can sit in my Monday night. So that will be a Monday morning for you. So we just first class, you missed the first class, the introduction class, right? This one. So this one will take 45 minutes to 1 hour, so we can complete that one. Because I already asked Prakash to share the recording with you. He said he will do that. If in case he has not done that, so Monday night for me is like Monday morning for you. Is that okay, Jai, with you?
Yeah, that's fine. I think Monday morning is my Sunday evening.
No. Monday night for me, that will be Monday morning for you. Yeah, that will be Monday morning for you.
Yeah.
The time can be around 8 p.m. 8 p.m.